Hello and welcome. My name is Jason Baum, and today we're talking about humans on the AI Time Journal podcast. So thanks for joining me today. As I said, my name is Jason Baum. I'm the Director of Member Experience at DevOps Institute and host of the Humans of DevOps podcast series. It's all about humans for me. I'm a community builder, people connector, and conversationalist by trade. So, on this All About Humans series of the AI Time Journal podcast, we're going to dig deep and get to know the people behind the tech, behind the data, and behind the AI. My guest today, Varun Ganapathi, is co-founder and chief technology officer at AKASA. Varun's passion is developing novel algorithms to power great products with a focus on healthcare and improving the patient experience. Varun has a bachelor's in physics, an MS and PhD in computer science from Stanford University, and during his time at Stanford, he focused on machine learning and computer vision. His doctoral thesis was the basis of the first company, Numovus, which was acquired by Google. At his time at Google as a research scientist, Varun went on to create Terminal.com, which was acquired by Udacity. Udacity. Udacity?
That's right.
Varun went on to create Terminal.com, which was acquired by Udacity. With financial complexity crippling healthcare in America, Varun and AKASA are on a mission to fix that by pioneering unified automation for healthcare revenue cycle management, bringing together the best of people, data, and machine learning technology. Ultimately, they focus on helping health systems be better stewards of their healthcare dollar. Varun, welcome to the All About Human series of the AI Time Journal podcast.
Thank you. Thank you for having me.
Absolutely, my pleasure. So, Varun, let's talk about the healthcare industry, shall we?
Sure.
So, so when we say, look, the healthcare industry, I feel like so many people that it's like the one thing we all have in common.
Mhm.
We go to the doctor. Well, we should go to the doctor at the very least, if we're being good stewards of our bodies. But so that's the one thing that we all have in common, no matter what. And so the healthcare industry is incredibly important to the fabric of the world. And so when we talk about the financial complexities crippling the healthcare system in America, at least, well, that brings many thoughts to my head. So tell me what AKASA means by that, maybe.
Sure. The financial complexity in healthcare is really about all the different rules and regulations that govern what services can be paid for and how much should be paid for those services, how to handle things like if someone has multiple insurances, maybe they have their own insurance and their spouse has insurance. There's a lot of rules regarding like how much does the first insurance pay, how much does the second insurance pay. There's just each of those rules is really determined by contracts that occur between insurance companies and providers, not to mention just properly writing down what services were performed into a format that's like structured and standardized. All of that just takes a lot of time and energy, um, which is important, but it also is like takes a lot of human time. And it's something that we feel like if we can use machine learning and AI to um, save all these doctors and hospitals time in doing and navigating that complexity, that will be better for everyone, right? They can focus on healthcare rather than documentation or like like proper submissions and like handling of that, and we can solve that problem for everyone at scale. So that's kind of what we mean by that.
I remember the first time that my doctor's office switched over to everything being virtual to digital, right? When they take the old file. I used to work in a health care system, and I
Hmm.
remember those old school files, and there's thousands and thousands of them that you need to file. Honestly, that's all we did all
Yeah,
day was file, and I'm sure it's the same thing, but now it's just digital.
exactly.
So, what development in AI in healthcare has been the most interesting in your opinion?
In healthcare and AI specifically, I mean, I think what's cool, a lot of the stuff we're doing, we're really leveraging a lot of the developments that are being made in computer vision and natural language processing more broadly. Like we're making huge advances as a society in those things. And some of the recent work like Dolly from OpenAI, they're literally combining both of them together. It's like computer vision and text, and then being able to show that computers to some extent can't understand the relationship between the two. We apply and develop our own research, sort of taking that and then tailoring it to our domain, which is like healthcare. And so a lot of things translate over. So for instance, one of the problems that we solve is dealing with all of the documents or insurance cards and things like that that are uploaded to the systems. All of that needs to be understood and turned into a structured form that can be recorded and manipulated digitally. We use computer vision to solve those sorts of problems. We use natural language processing to be able to read doctors' notes and understand them, and then translate them into proper claims automatically, for instance.
That
So
must be the hardest part, reading the doctor's notes. It's pretty well known that doctors, if you want to be a medical doctor, you have to have the worst handwriting in the world. So, how does a computer understand it when we have a hard time understanding?
right. Actually, the good thing with the digital, the transformation that you described is now doctors have to write their notes. They have to type them in, or at least dictate them. So at least, we can use voice recognition, or they just type it in. And that definitely saves a lot of effort. I would agree. Having to solve reading doctors' handwriting might be beyond the scope of today's computer vision. Maybe another 50 years for that. But
I can't imagine the number of mistakes that must correct that used to happen um, back when I was doing this a very long time ago, and just sometimes gosh, the milligrams that you would read. I mean, there's so many things that can go wrong when you read it incorrectly. That little change probably has helped.
for sure. Um,
So that's great. So machine learning. Let's talk about machine learning. Do you think that's going to displace RPA?
So that's a great question. The answer is yes. The reason is, well, actually, let me put it this way. Machine learning enables us to do the things that we have to hard code by hand now with RPA. And then it will be able to do way more. The main value of machine learning is not having to code by hand, um, lots of special cases to deal with problems and to automatically generalize well to new situations. So rather than typing in like exactly what you want a computer to do, which is what we do with RPA, with machine learning, you show the computer what you want it to do, and then it learns from that, and then it can do it by itself. And so I think what that really opens up is, it enables building these sorts of automations much more efficiently, and also enables it to work and not be brittle, like in the face of changes. So for instance, in computer vision, we expect that if you look at a car from a slightly different angle, like 10 degrees offset, or if the car is slightly smaller, or whatever, it's still, we should be able to still recognize that it's a car, right? Like we wouldn't expect it to fail. With a lot of RPA today, that won't work actually. Like if you move a button, it will just break. What we do internally is we actually have computer vision that looks at the computer screens to understand what's on them in a semantic way. And then that way we can handle things like changes, without actually failing. But more importantly, beyond even, I would say it's sort of like what RPA does, or what these solutions like, or even if we extend it to machine learning, that's only part of the problem that we have, which is it enables us to build APIs effectively on top of systems that don't have APIs. So like if you need to interact with an electronic medical record, it's like some old legacy app. Sometimes it's really hard to get data in and out of it, right? And so these technologies enable us to retrofit them and like turn them into APIs effectively that we can use. The other part where machine learning really comes to play and like nothing else can do really, or it's extremely hard, is deal with unstructured data like images and text, like like the things we do with understanding doctor's notes, understanding images of insurance cards, or even oftentimes we'll actually interact with websites and extract information from them automatically, or historical or documentation of other forms like the CMS rules on like how do you code various things. All of that data is very hard. It's like basically extremely hard for someone to handle manually, like we're just writing programs. And so machine learning really, that's like where it really comes to its power, is like being able to handle all of that and solve these problems the way a human would. Like sort of like wherever a human needs to make a decision, we try to leverage machine learning to at least make the easy decisions, right? If there's a common case that occurs hundreds of times, thousands of times, we can observe that that's happening. The algorithm will pick it up and be like, cool, I know how to solve this automatically, and I can just skip that step. And that's really where we see machine learning coming to bear.
Yeah, that's great. I feel like it's in some ways it like makes the mundane just not have to be part of our process anymore.
Exactly.
Yeah, I mean that's pretty amazing. um, so AKASA's revenue cycle program. Tell me a little bit about it. How does it function, and how does human capability improve it?
Great question. So the way it works is we try to connect into a health system the same way a normal person would. With the addition, like so for instance, today when people work remotely, the way they do this sort of work is they connect in using a remote desktop program. So essentially it's like they log in at home, they have a computer. That computer actually is just a window into their actual computer at the office, right? And they, see the same screen, et cetera, right? So imagine if you just took that human and you replace it with an algorithm instead that like basically can look at the same screen, type in things like the same way a person would, and use the mouse the way a person would. That's like the most low level way to interact with a health system. The other way you can interact is by collecting all of these structured data feeds that health systems have. Like there are all these like formats of files. I won't go into them, but there's a bunch of them. We take advantage of those as well. And what we do is we learn what humans are doing, and then we have our algorithms uh, find the common cases, and then we, like you just said, eliminate the mundane. Our system will say, okay, uh, I'm going to go through and look at these queues of work that people are working out of today, which is what they do. They have these queues that just have tasks that come in, minute after minute, hour after hour, and they're just processing those tasks, right? AKASA will go look at those tasks first and say, okay, this task, AKASA knows it can just solve this, and it will just do it and just take it off people's plate. So magically, it's sort of like work just decreases, and it's like all the boring stuff is just sort of like taken care of for you. And humans can focus on the really hard stuff. And this is particularly important because there's a really a big shortage of staff for these hospitals in this space, not only because of COVID, but just generally. And so they have more work than they can handle. So this is really, some of our customers say that this really has helped them tide over like these staffing shortages, because automation is helping take away to solve this work that they would otherwise need to do.
Yeah, that's a big issue, the shortage of staff. So yeah, this is fantastic. I'm sure it's a huge help. Who are some of the companies who are implementing the AI well?
So it's interesting. I think AI is really, I would love to mention startups, but a lot of them are enterprise, like B2B. And so it's hard for me to like directly say like they are implementing AI well, other than just like saying my friends' companies and saying, they're doing a good job. But
Go ahead, say it. Give them a
my
shout
friend,
out.
a friend of mine runs Zoox, and it's a self-driving car company. I think they're doing AI really well. They're owned by Amazon now. From my personal experience, I would say, I use Siri all the time. And, yeah, everyone, probably a lot of people have used Siri, and it works really well for me. And so that's like a way in which AI is, I think, implemented great, and everyone can just leverage it and use it. Yeah. And there are tons of other examples. A lot of companies are leveraging AI now. The technology is, um, it's very versatile. So it's being used in thousands of ways all over the place. In a lot of ways we may not even feel or directly experience, um, like how Netflix chooses what shows to recommend to you and so on. These are canonical examples, or maybe how like YouTube Music decides like what songs to suggest. In the enterprise space, really, it's um, I think we're doing I think we're obviously trying to apply AI the best we can, and it's working really well, and we're able to leverage this technology.
Yeah, I'm glad you said Siri because I do find I mean I use it all the time as well for pretty much everything. What's scary is now my 4-year-old daughter uses it too, and now to my Apple Music is all messed up the algorithms because she's making requests for My Little Pony, and I'm like trying to listen to my music, and so now you should see the confusion I think that Apple has trying to give me music suggestions. So what changes have you made to improve AI in your own company?
Great. Well, I think one of the big things we've done is we wrote this paper called Read, Attend, and Code. It was about medical coding. It's like, how do you read doctor's notes and turn them into these codes, which is sort of like a machine translation problem. One cool thing that we did is rather than just giving the algorithm data, historical data about what's happened, like historical notes and then historical outputs, we also added some additional information in the form of like essentially a dictionary telling the computer, here's what every code means in natural language text. And I thought this was very interesting because it improved the performance a lot. And it makes sense that what we're basically saying to the computer is, don't just treat these outputs as like just arbitrary tokens. They have meaning. And like, obviously what is meaning to a computer, it's hard to say, but like, at least we can say like this natural language English text is there and it explains what this token means. And so the algorithm can then say, well, these two different codes, like code 85 and then code 92, like instead of just thinking of them as like two random numbers, it can say, oh, they're actually similar to each other because one of them is about like breaking your left leg and the other one is about breaking your right leg. I'm using random examples, and these are definitely the wrong numbers, but the idea is that it can actually look at the underlying symmetry between those tokens and then leverage that in making decisions. And that allows us to solve problems where um, there's an underlying sparsity of data where, essentially like I see these, there are tons and tons of codes. And so you're not going to get, even if we train on a very large health system, you're not going to get tons of samples of every single code. And so this innovation we brought to bear really helped with that. And I think actually more generally, if I would say, I think it would be really cool to see, are there ways we can modify the behavior of our machine learning algorithms, not just by changing the data we give them ahead of time, but actually by like adding this auxiliary information about what we wanted to do, literally in natural language. I think that would be really cool. So we can just describe like modifications, and that way we can handle things like data drift. For instance, when the world changes, historically, it's like you just need to retrain the model or like kind of like start from your original data and then say that more recent data counts more, and like that's how you have your algorithms learn to deal with changing world. Maybe there's a way you could literally like add English that describes like, okay, it's the same as before except in this one situation you do this instead of that, right? Like if we could actually do that, we're not there yet, but I think that's, we're those sorts of things would help us a lot, and that's the sort of thing we're looking at.
The English language is an interesting example because there are so many examples of things that don't mean what they're supposed to mean when they're presented in certain way. That's such a good example. Um, so, what are some of the most common misunderstandings you get, maybe from people about AI?
Hmm. There's a famous quote, uh, is that AI is whatever we haven't solved yet. I forget. I think it's Douglas Hofstadter who said this quote. We can fix it. I think it's Douglas Hofstadter said, AI, we call it AI if we haven't solved it yet. I'm paraphrasing it. So literally, it's like every time there's a problem, you know, it's like automatically look at, a string of text and like figure out what's in it. They're like, oh, it's just optical character recognition, right? OCR. Under the hood, it's implemented using deep learning and so on. So it is AI, but like it's whenever a problem, like whenever we can solve a problem sufficiently well, it like no longer counts as AI, it counts as like something else. And so I think that's what's interesting about the misunderstanding about AI is that everyone assumes it's just a thing that it's sort of like, I just hear people say, when we use X, when we do X, Y, or Z, oh, that's just natural language processing, or that's just computer vision or something like that. And it's like all of these are actually AI. It's just like whenever it gets sufficiently good, we don't call it AI anymore. So I think that's just like a funny misunderstanding that I sometimes hear people who are not familiar with like how these algorithms work will say. Um,
I'm unfamiliar with that. That's a really cool way to look at it. I guess if I'm to paraphrase, it's almost like AI is the problem,
yes,
and then whatever we end up calling it is the solution.
exactly. I
Yeah,
think that's a great way. That was a good summary of what I was trying to say for sure.
I'm not the smartest person, but I can summarize really well. So what are some safety measures? I want I, like I think on the last podcast that we obviously talked about the machines, and the machines are coming and they're going to get you, and we talked Terminator because I think that's the most common, at least for so many people, where you go to when you talk robotics and you talk machines. But what are like AI? There's so many uses and applications, like you were just talking about. What are some safety measures that we could take to have AI used responsibly?
Well, so that's a big question, and I think I can't say that I have like the answer or anything like that. And it's a good point. Um, I think for sure what we do at AKASA is that, and our AI has a very limited domain of like what it does. Um, we try to make sure that there's a human in the loop always. So we'll have quality control checks on a daily, every day, or X% of work is automatically sent through people. So we confirm the AI is doing what it's supposed to do. These are sort of measures we have in place to make sure we're producing good results. Um, we also train our algorithms to solve specific tasks. So I think that for one thing, this would be a very limited way. I'm not suggesting that this is all we do, but if you think of, instead of building like a general purpose robot for your house, we've like in our today what we have are like washing machines and like dishwashers and so on. If we think of AI similarly, where we like constrain like what it's supposed to do to a specific domain, and it's like an appliance in some sense, that does, obviously it can do harder things. That might be one way to sort of ensure safety. Now I think that might prevent us from doing things that like would be really convenient, but it's one way to ensure that like we're using AI responsibly, is at least like constrain the input output scope of like what we're doing with it. um I think where it gets tricky, like once you give AI the ability to move, that's where I think things get really hard, because obviously, that makes it harder to, that like harder to solve.
Yeah,
Just
we've all seen
ensuring,
that Black Mirror
yeah,
episode.
yeah. Like so, I think is the tricky part. But even if it doesn't have the ability to move, the counter argument would be like if it can just like connect into the network and like hack into servers, like I'm sure there's like 50 movies about that too. Um, I think if we, I one thing I will say is though, I think, well, there are many ways to use AI. It's not going to just like randomly do that. Like we would have to set things up to cause that to happen. And it would be a very surprising feat to happen. We're, I think, a long ways away from that. And I think there are a lot of domains where we can leverage AI and like not have to worry about that, as long as we constrain the input and output scope. And it's really just, at that point, it's just math. Like we're just doing like lots of matrix multiplications and like solving something as a result of that. It's unlikely that thing is suddenly going to become conscious and do something by itself. And so I think there are a lot of ways we can leverage AI, as long, at the very least, if we focus it on specific targeted tasks, that should be one way to do it.
Thank you. Yeah, so um, if I'm new to tech, or maybe I'm an IT professional, but I'm looking to change my focus. Um, what can I do to have an edge in my career, given the impact of AI?
Well, okay, well, it depends on who you are and like what you think your strengths are. If you think you could actually learn to do machine learning, and you have an inclination, you're interested in it and you like math, there's definitely, tons of courses out there. Udacity has them, that will teach you machine learning and enable you to start leveraging it, right? And there are a lot of ways to apply AI today which don't require literally writing everything yourself. Like you can use um, pre-made essentially toolboxes there. You can feed in data and you can get outputs, and you don't need to like be a complete expert in order to do that. So that might be one option. Or you could go become an expert, which, I mean, there's a huge demand for people. We have a ton of demand for people who know machine learning. We would be happy to hire people to do that. So there's a lot of I would say like one option is to actually learn to do it. That's another one thing. If you're someone who is unlikely to want to actually do the engineering, I think as a product manager or technical program manager, understand that machine learning is not like other programming in the sense that it's not in some sense it's not there's a lot of iteration a lot of the time on the data set itself, and so learning, just like seeing and learning more about it and learning how people apply it, learning like what the standard processes are for cleaning your data and then applying it in a situation, and realizing there's a lot of iteration there that has to happen as you like improve the data, improve the model. It's not as cut and dry as other programming where you just write the code and it works. Oftentimes you have to actually like mess around a little bit and run lots of experiments. Um, so I would say just like learn more about it, and that way you can like work well with the machine learning engineers you do hire to solve these tasks. And the final thing I would add, actually, really important point, actually, maybe is what I've learned in AI is like try to leverage it in places where you sort of play to its strengths. So one of the things is if you take a generic classification model or any ML model, it will output an answer, and then and it will usually also, you can get it to output a confidence rating of like how sure it is about that answer, and that confidence is not going to be totally correct, but it will give you a sense of like uh, can you trust this answer or not? There will be a lot of areas where it's not very confident about the answer. Like if you actually plot the curve of like how often is it right, given its confidence, like there'll be a large space where it's like only like right 75% of the time or right 90% of the time, and so on. And you can plot these curves. It's unlike other tasks, we have to sort of design the applications we build to be robust to error, in the sense that if the algorithm is right 90% of the time, that is still useful. And I think that is a really tricky thing. Like if you look at the self-driving car world, being right 95% of the time is not enough. Like you have to be right like 99.999% of the time, right, in order to do a good job. And so I think that's where it gets really tricky, is you need to plan around that. But for a voice recognition system, as long as it's not being used to control some like essential thing, like it's not the end of the world if it's wrong once in a while, right? Like a person will just be like, no, cancel, re-say the thing, right? And like that, hopefully it works better the second time. So as a product manager or other people who are non-engineers, when you think about AI, like try to structure it, like imagine it as like a person who just has some error rate that they will just like mess up some percentage of the time. How would you leverage them well in still designing an overall product that's good, right? And it's really like make sure the cost of an error is not super high. That's why we chose our domain, is that if we make a mistake, I mean, these are not like every one of these decisions is reversible, right? Like if we send out the wrong claim, we can say there's a mistake, let's correct it, right? So that's why we chose what we did, is to like try to avoid like when there's a mistake, try to avoid serious consequences of that. And that might be a good way to use it if you're outside of an engineering domain.
Yeah, as opposed to like the artificial surgeon, who I could see that would be pretty high error. You would need to be 100% for that one.
And someday we will get there. Like I mean,
Yeah.
as the humans are also not perfect. That's the other funny thing that we've learned, is that,
Yes.
and I learned this at Google and at here, is like when you have humans label data, you know, in the things that we've told people to label, it's like 90, they're like right 96, 97% of the time. They're not at 100%, right? And so humans are not perfect. So really it's like, when do our algorithms get better than human, right? And that's like kind of, that might be a reasonable threshold.
I think that circles back to what we were talking about at the beginning in the doctor's notes, right? And not only maybe the doctor made an error when writing them, or maybe the person who's interpreting them is seeing them incorrectly. Maybe then they go and they file it incorrect. There's so many chances for error in those processes. So maybe right there, the improvement is so significant. I'm just thinking of a few off the top of my head, where it could improve drastically from just some simple changes, quite frankly.
Yeah. And what we found is actually, like you said, in healthcare specifically, there are a lot of errors like in the medical billing space that result in what they call surprise bills. Like a person is just like gets a bill, it's like $700 or something. and you're just confused. You expected like your insurance to pay for that, and this happened to me, and because I'm now in the space, I was like, let me find out what's going on here, and it turned out they billed the wrong insurance company, and therefore they just and like that insurance company said no, obviously, and then they just sent the bill to me, and then I called them up and I said, actually, this is my insurance, like, and then they fixed it. And so I think that's where AKASA is adding a lot of value, is helping prevent people from getting these surprise bills by preventing these errors up front, which is super valuable. I mean, today, just due to the shortage of people, they can't afford to literally check every single thing like super thoroughly every time. And so they sometimes have to just say, we'll do our best. If there's a problem, the patient will let us know and then we'll fix it, right? But the problem with that, and I understand it's expedient. The problem with that is like the patient gets like a scary experience as a result, right? And it's like you're all of a sudden like, whoa, like what's going on? And you may not even know, because like most of the time you get an invoice, it's usually correct, right? And so you may not expect that. And so I think that's where the fact that machine learning can have a higher accuracy rate than a person can actually really help a lot.
It's funny. I literally just went through this myself, where I got an invoice for someone that's not in my household for a hospital that I've never been to. So there you go. And by the way, then once you're in that loop of getting these invoices, it's very hard to get rid of them because the
Yes.
amount of people who probably call and are like, I don't know that, are I'm sure there's a ton of them. So yeah, once that error's been made, it could be tough to fix.
Mhm.
So I guess what's next for AI in healthcare? And are companies adopting AI fast enough? That's kind of a two question there, but what is next? What's on the horizon?
Well, maybe you could clarify horizon. Do you mean like a year, 2 years, 5 years, 10
Yeah,
years,
let's say within the next 3 years.
3 years? Okay. Um, I think that for us, well, there's a lot of work for us to do to just solve fully the problem that we are tackling. There are a lot of tasks that occur in like the healthcare revenue cycle documentation, the whole like what I would call like the back office of healthcare. And every year we just add new capabilities. Every 6 months we add new capabilities, and like we're gradually expanding to tackle all of that. And I think that process, we will have made like a tremendous dent in that within the next 3 years. So we'll have solved like a large percentage of like I think what needs to be done in revenue cycle within 3 years. So I'm really excited about that. More broadly, I think that AI will start to be used more on the clinical side of healthcare. Maybe there are ways to save doctors time. That's something that we're always thinking about is, so we're saving time on the back office section. I'd love to save the time for doctors as well. Not by automating tasks away. I think human in the loop is really, really important. But like maybe save them from having to do as much mundane work. If there's a bunch of things like getting all of the medical records ready before they see a patient or things like that, I feel like we could probably help a ton and really just make the experience more efficient for a doctor so they can just do their job super quickly, but and accurately. Like everything is present for them. More broadly in society, yeah, the next 3 years, I'm sure self-driving cars will start to become more and more prevalent. I think it might start, like just at nighttime or other times when drivers are less available, like where supply is low and then therefore traffic is low. That might be a place where we see self-driving cars happen first, and then they start, slowly happening in other times of the day. Those are sort of would be my estimates. It's really hard to tell though what will happen.
Could you imagine automating the triage process at the ER? I think that would be an area that could really benefit from it, especially with what we've just went through the past few years. I had an ER visit during the midst of COVID, and they were triaging out in the ambulance bay, triaging out in
Wow.
the. I'm in the New York area, triaging in the driveway. I mean, impossible. And I mean, you'd think about if they could just get people through the process for them faster. I wonder, especially when it's just like, okay, what's your height? What's your weight? There's certainly some ways that they could
Yes.
probably automate that.
Yeah,
Uh,
maybe they could triage remotely and then
yeah.
just like immediately just tell you, okay, we're probably going to be able to see you in like 2.5 hours, like
Yep.
come then, right? Like
Come
as opposed
back.
to like, yeah,
Oh,
as
could
opposed
you
to like
imagine?
waiting in the ER for like hours, right?
That
Yeah.
would revolutionized the ER for, I think, so many. I mean, yeah, there goes your 8 hour ER visit where
Yeah.
now you're frustrated. Yeah. Um, so I always like to end my podcast by asking a question of my guest that's a little more personal, because this is the human series. So Varun, here's your question. This maybe it's a little bit of a thinker, but if you could be remembered for one thing, what would it be?
Hmm.
I could tell you like the answer that my guest last month said was um, that he'd like to be remembered for making people's lives easier, which I loved. I love that answer. So simple.
And it isn't something I've done yet, right? Like, can be something I want to do.
Anything, yeah,
Okay.
anything that you want to be remembered for.
It's a great question. I think I would like to be remembered for um, dramatically improving like the quality of healthcare worldwide and actually making healthcare cheap, more affordable and higher quality, and actually resulting in like actual lives saved due to what I do, like, or at least in part due to what I do. I would love that to be something to remember for. It's like everyone in the world is like better off, and are more taken care of and like live healthier, longer lives, um, and have better emotional experience with the whole process as well. I think that would be a good thing to be remembered for.
I love it. I love it. And because anyone who has had experience in the healthcare system, and I'm pretty sure that's everyone, whether for yourself or someone else, sometimes that could be just as frustrating, if not more. I really appreciate it. I love that. And thank you for all the work you're doing.
Thank you.
And
Thank you for
keep it
having me.
up. Keep it up. Keep making it easier. It's truly appreciated. And thank you so much for being on the podcast.
Thanks for having me.
And thank you so much for joining us for this All About Human series of the AI Time Journal podcast. I'm Jason Baum. If you're in the DevOps space, please visit DevOpsInstitute.com to join our community. Until next time, stay safe, stay healthy, and most of all, stay human. Live long and prosper.